So I'm going to explain how the 3JS material classes, the attributes that you define on the 3JS material classes are updated inside of the shader, on the 3JS shaders. I'm not going to explain all the details, just the parts that were confusing to me. And I already did a string to explain the rendering cycle. So I'm going to link that on the description. And I'm probably going to have to take a bunch of pauses because it's actually really confusing. So I want to explain the part that that I wasn't sure on the last time that on the last video that I talked about this. So that's pretty much the sequence of function calls here. So the first function that is going to call is the render. You're going to pass the scene in the camera. Then on this one, you're going to call render scene, render objects, and all the way up to this part. And first, I'm going to explain the uniforms, which are related to the fragment shader, and then I'm going to explain the attributes, which are related to the vertex shader. So on this set program, this variable here is going to be set to true, which is responsible for the control flow. That is going to determine whether or not this get program function runs. So the first time that it's executing the rendering cycle is going to call that get program, which I wasn't sure, which is this function here. And I wasn't sure last time that I talked about this if it was going to call it or not, but now I clarified. So this stuff here, because this is set here, and this is a class that is set from the beginning, these properties, which is this class here. And this creates a map between the object and the, I think it's parameters, or the object or the material, but first time that this gets called there, this is going to be an empty object because it didn't create a mapping. So it creates the mapping between the material and this empty object here in the beginning. So this is going to be an empty object, and because it's an empty object, this is going to be false. So it's not going to pass through this, and it's going to go here. So this variable is going to become true. And I'm talking about the first time that it's going to render the scene. And then it's going to call this function here to get the program. So this is the function that the sets material properties, uniforms to material parameters, uniforms for the first time. So the material properties, or the material parameters is an object. I'm going to show that on the source code. But it's an object that contains the specifications of how, what kind of variables the material is going to have and stuff like that inside of the shader. Then it goes back to the set program function, and there's another control flow variable, which is this refresh program, which is true in the beginning. And because it's true, it's going to call this other function here, which is materials. And this materials is a WebGL materials, which is a class that is initialized in the beginning as well. Just go here. As this class here, WebGL materials. So it's going to call the function from this class here. And this is one of the reasons why it's kind of confusing, because it initializes all these classes here. And then at some points, it uses functions from these classes, and other points uses functions from other variables and stuff like that was set inside of the other functions. So I really didn't like the way that they did this here. But I think they did this way because of the way that things evolved. So like it's understandable. But they're gonna call that function from this class here. And this is the function that sets the uniform values based on the material class values. So maybe let me just search for this and then I'll show the source code. So it's this part here. So because this is true in the first time that it renders, it's going to hit that condition. And here, I think it's inside of the set. No, it's after it gets back from this. So this one initializes the program class. I'm going to go over this one after. Just going to go So like this is the first time that it sets the it uses the values that you set on the material class to update the values that are going to be used later on the actual shader. So these are the way that Three.js works is that each shader, they have default shaders, and then each default shader has a bunch of include statements, and they include statements determine which kind of other shaders are going to be used to form that one. So it's like you have one shader that works kind of like as a template, and then you have shader chunks, which are strings that will be replaced by the include statement. So yeah, the shader lib ones are the default ones. So for example, we have this one that has these includes here, and each includes a shader chunk, which is stored here. So there are going to be functions inside of the program class, which is the class that creates the program, that are going to replace include statements with the actual code of this other shaders here, this code here, to build the final code that is going to be used to create the program. So each one of these is related to that. So you can see that each actually, this is the material class that you're using as part of the mesh to render stuff. So check to see if it's a mesh basic material. It's going to go through this function here. And then this one is the one, the main ones that it uses. Maybe I can look into because I'm trying to create another project where I'm simplifying everything and just leaving the stuff that I'm going to need to build it from scratch. So after cleaning up the mesh basic shader, the shader that is used based on the mesh basic material class, for the mesh basic material class, this is the code that I got. And so you can see here that in order to change the actual GL frag colors, it uses these variables. So the main variable that it's using is this diffuse color, and these are the two main variables that it actually uses on the shader. Once you remove all the other options that they allow you to put, but like the simplest version possible, these two variables here are going to be used to update the value of the GL frag color, and these values here are set on the class on the material class color. Maybe I can open the mesh basic material. And so you set the color to the parameters here, or this color here. So this color eventually is going to be used to update the other color, these colors on the shader here. So the color on the material is going to become this diffuse here on the actual shader. And then you have the other value that is opacity, I think. There's somewhere here, either on this one or on the material class. I don't remember if I see, yeah, here, opacity, which I think is just gonna, it determines how visible the object is. It's just like the name says, the opacity. So this is the first line where this happens for the first time. It's getting from the uniforms opacity value and is making it equal to the opacity of the material. And then here it checks to see if the material has a color, which is this value here. And if it is, then it updates the value of these uniforms. And the uniforms are going to be the thing that is used to actually update the shader, which is this value here. As far as I remember. It's passing uniforms here, which is this value here. And I'm going to go back to explain the programs. But this is based on the program that it creates there. Or these material properties, which is the stuff that I just explained. So this one is initialized on the get program here, because this thing is going to be an empty object in the first time, so this is going to be true, and then it's going to go over here. And then on this function here is going to initialize the material properties. Should be the parameters of the material properties and other values should be equal to the program, or to be equal to the program and the materials that are created inside of the program. So yeah, basically it's just the uniforms that are going to be used to update the shader, this variable here. So it's passing this variable into the other one, and then it's copying it's updating the value of that object with the material class. And then right after it does this, this is the function that actually updates the shader. So right after it copies, it updates the values of the uniforms that are going to be used on the shader based on the values of the material class. It calls this function, and it passes the material property, the material properties and the uniforms. And then here, this is the function that is going to be used. And this is kind of confusing as well. So this set value is the thing that is actually going to set the value inside of the shader. But the way that it works is that this WebGL uniforms is going to be initialized when you initialize the program class. And then it calls this parse uniforms function here. And then it's going to store other classes inside of this part here. So this set value here that is calling on this function actually comes from another class, which is either one of these, which is going to depend on the kind of variable, the kind of uniform variable you're setting. And this is another part that is very confusing. So this is the actual set value function that it is calling there. And this one is just going to select which kind of WebGL function is going to call. Because depending on what kind of uniform you have to call different functions. Because WebGL doesn't have function overloading. So you have to specify for different floats, vectors, and matrices, depending on the size, different kinds of functions to call. So this is just a generic function that receives the type, and then based on the type of the uniform, it selects what kind of function you're going to call. So let me go back to the programs to explain. Yeah, so I think this is the whole thing as far as the uniform variables that I wanted to explain. So the main thing to understand is that it's going to call get program in the first time that it renders. Then on this one, it's going to set the material properties to be equal to the material parameters. So maybe I should show this now. So on this function here, this is the function. So this program cache is also initialized in the beginning, and this is the WebGL programs class, and is a class that is used to manage what kind of shaders are going to be used, and is also the class that creates the programs. Is this class here. So you can see that you have these default shaders here, and then it's going to select the get parameters function is this one. Let me go back. So it's calling this function from this class here the first time, and it's passing the material and other stuff. This material comes from the, I explained more on the last stream that I did about this, which I'm going to leave on the description, but it's just basically the material that you pass through when you're initializing the mesh that you're actually going to put on the scene. So in my case would be the mesh basic material. So it's this class here. So it's passing this to this, it's calling this with the material there. And then in this function here is going to initialize the parameters, which is this object here. And then this is the object that is going to use on the other material properties object to update the actual shaders based on the stuff that I showed there. But I'm going to follow the execution now. So it's calling this function based on the materials, and then it's selecting the shader based on this object here that has several different default shaders, and based on the material type. So it's going to select the shader ID based on that. And then it's going to get this shader based on another file that has these objects here. So in the case of the mesh basic material, it's going to be this value here, the basic. So it's just returning this object pretty much on the other call. Yeah, it's returning this object. So it's going to become this. And so it's pretty much getting the vertex and the fragment from here, which comes from the shader chunk. And the shader chunk is the file that has the selection of all the other shaders, these shaders that I think it's the ones that you have here. So the case of the mesh basic material would be mesh basic vert and mesh frag vert, which are these shaders here, mesh basic vertex and fragments, which are these ones, I think. Yeah, it comes from this file to have the vertex and the fragments based on, so it's pretty much using these shaders here for the mesh basic material. And then sets initialize the parameters, and I think it returns the parameters, which is just this massive object with all this information. Then it's gonna call this other function here and pass the parameters, which is the object that is just initialized. And this function is the one that is gonna initialize the program for the first time. So maybe it's not this one, it's the next one. I think it's acquire program. So I don't remember this function very well. Whatever, it doesn't matter that much. It's this one. So here is going to try to get this. So it's caching the programs based on this program cache key here. And it builds that based on this, which is based on the what kind of material it is. So based on that massive object that creates here, which with the parameters, is just going to create a massive string that uses the massive string to cache the string with the, I think it is with the program. So just caching the programs that are being used based on the parameters. So it returns the massive string here. And then, so in the beginning, this programs here is created by this here, because the material properties doesn't have a program. So the program's variable is going to be undefined in the beginning. Because I believe that the material properties is that empty object from the beginning for the other function. Let me go back to. It's going to be, so remember that I said that this is going to be an empty object, so it's going to hit this condition here. And then because it hits this condition, it's going to call this function. So in the first time, the material properties is an empty object. So when it gets to this part here, the programs are going to be undefined because this is an empty object, so this doesn't have programs. So it's just going to create a map, which is the map for the programs, and then initialize on the material properties. And then because it's an empty map, it doesn't have the cache, the program cache key yet. So this condition, this condition is going to be the one that it goes through. And then on this condition is going to call this function, which is the acquire program function from this class here. And then on this one is going to create the program class that is going to actually create a program from the shaders, from the fragment and vertex. So it passes the cache key, the parameters, and this binding state here is also important, and I'm going to explain once I get to the point where I'm going to explain how the vertex attributes are used to update the shader. But on this initialization here, it pretty much does some, it calls some WebGL functions to create the program and to create the shader, and it does some string logic here to create that final code that's gonna make the shader code. So it's basically selecting the shader file that I showed for the vertex and the fragment, and then it is adding additional stuff here on top of the file based on whatever the values of the parameters are. Because remember that the parameters are based on the material, on the stuff that I showed there, on that function that creates the parameters for the first time. All this stuff is going to be based on the material. So based on what kind of stuff you put on this class here, which is the one that you're going to use to initialize the material that you're going to use on the mesh, based on these values here, is going to create the parameters object, and then it's going to use that on this class here to determine what kind of variables it's going to put on the shader that you're going to use, along with the default shader code that it uses. So this is just the prefix. Then it has this function here, and this is the one that is used to replace the code that I talked about there, the include code with this code here. So replace this includes with the code for the respective chunk. Then it does more stuff here, pretty much manipulating everything. Then this function is the one that is used to actually create so this is the final string that's going to have all the shader code Then it calls this function, passing the string. It's going to be the type of the shader and the string that makes up the source code of the shader. So it's going to be both vertex and fragment because of the way that it calls there. And these functions from WebGL are going to create the actual shader object. Then it attaches the shader to the program that it passes from the other class, from this class here. Oh no, this actually creates on this as it creates this class, it creates a program there in the beginning using WebGL. Yeah, here, this line here. So that's pretty much it. Then links the program, and then later on it's gonna delete the shaders after it linked the program. And this is another important part here. So let me go back to the execution. It's very confusing. I try my best to explain everything. So this is the first time that it's gonna update the material properties uniforms with the parameters uniforms. So remember that well, actually I skipped this one. So yeah, before it creates the program, it calls this function here, on here, passing the material. This is gonna be the variables there from the other file that I showed. So the uniforms are gonna be this thing here, this value of this thing, and it's just gonna be actually JavaScript values. These values here are actually JavaScript values, so they're objects, and they hold the information of the uniforms that you're gonna use to update the shader. So yeah, actually I missed this one, but that's the point where it saves that those values, which are JavaScript objects on these ones, they're gonna be related to what kind of information or what kind of data you're gonna use to update the actual values on the shader. And then this is the point that it puts the uniforms on this material properties uniform. So after it does all that, then it goes back to the other function, to the main one. So yeah, based on what I just said, what's important to remember is that this line here, that it saves the uniforms, which are the variables that are going to be used to update the shader. And then once it goes back here, then it gets this variable here becomes the stuff that I just said, which is those other values here pretty much. So these values here, these objects, I haven't looked too much into it, but I assume that they just put everything into a massive object based on this function here. That just runs this function or a massive array to put all these objects here, depending on what kind of material you have. Because the material you have is going to determine what kind of what object you're going to select from this uniforms lib here. So it's just a massive array with all these objects here that is going to become this variable here. And then this variable is the one that is used to this and this one. And this one comes from the program class that initialized there on the getProgram class, on the getProgram function. It's going to call this one. And so it's the function from this class it is calling here. And this function is going to initialize this class here in the first time because this is going to be undefined. And this is the one that I was showing there in the beginning. So once it initializes this class, it uses parse uniform and calls this WebGL functions to get the active uniforms from the shader, which is the program. And from the program, so this function is just getting what uniforms the program is using based on the source code and the stuff, the code you use to create the actual program. Then it's going to call this, and then this one is going to set up these other classes here. And these are the classes that are going to set up the set value function. So it sets up this class and it returns this and then becomes this. So when you call set value here from this is the thing that I just explained. This set value function is going to be the one that these classes have, this class is set up. So it's going to depend on what kind of uniform you're setting up. and each one of them has its own implementation of set value, which is going to be either one of these functions, and then this function is going to be like a control flow thing to determine what kind of function from WebGL you're actually going to use to update the uniform, which is going to be one of these functions here. So you're actually calling one of these functions when this thing runs. You're just calling one of these functions because this is the thing there, and then updating the values of the uniforms inside of the shader based on this. And this one becomes the parameters uniforms, which are set up in the beginning there. Let me go back actually to this part, this getter uniforms. So these ones are the JavaScript ones. So I think that's pretty much it for the uniforms that I wanted to explain. There were some parts that I didn't. This one is the last one that it passes this variable there that is the other one. Is this one. So this is the one that I just saw, and this one is going to be the one that is JavaScript objects, and then it's passing that to this function here. So this one is, I think is this. So these uniforms are going to be the JavaScript objects there. These JavaScript objects going to be passed through this, which becomes this, and then calls based on whatever material class you're using. And then is accessing the values of each one and updating based on the material class you initialize. So just updating the values of this object here with the values that's of the material class you selected and the values you updated the material class with. And then it's using these values to update. So after it updates everything, then it calls this function, and this is the actual function that is going to update the shaders with the values from the class. And it does that, I assume, I'm pretty sure that this set value here is going to be the thing that I just explained, because this function is the same from it's the same function from it's different instances of the class, but it's the same function, so it's kind of the same logic. So this set value is going to become one of those functions there from one of these classes. So it's just like one of these. And that's what's happening there when you call this upload here. So just setting the uniforms based on the variables from the class. So hopefully that's not very confusing. So now I think I'm gonna close everything and just explain the attributes, which is also really confusing. I think I'm just gonna open as I need stuff. So I'm not gonna remember everything. Yeah, so hopefully it's understandable. So for the material, for the attributes are related to the geometry class, which is related to the vertexes. So maybe I should explain that in the beginning. So the way that it works is that you create the mesh based on the material and the geometry, and the geometry is going to be either one of these classes here, and all of these classes are going to inherit from the buffer geometry class. And the buffer geometry class is the class that is going to be used to manage the data that you're going to pass through the shader to update the positions. So the way that they do it is by creating vectors that are going to contain the data to create whatever geometry you want. And then they call this set attribute function to create a mapping between the name of the data, the name of the variable, and the data that's it's going to be equivalent to that name. So it's pretty much mapping here in the beginning. And this function is from the buffer geometry class. So it creates this mapping in the beginning. Then later on, along the way, it's gonna use this data that it sets here to actually update the shader that you selected based on this programs class that I just showed, which are also related to the uniforms, obviously because the program is both fragment and vertex. But I'm gonna go from the beginning and I'm gonna show the pipeline that I draw there. The thing that is confusing to understand is that there's a bridge that is made on the beginning. Let me show the execution first. So again, it's gonna go from render. So the first function that is related is the project objects. So this function is gonna be called inside of this render function, which is the first function that is called when you're rendering the scene. And then inside of this function here, you're gonna I did it on the C++ version, but I'm gonna show here. It's pretty much this pipeline here that this project objects is gonna call a class that it's initialized in the beginning, which is this geometry class. So initialize this class here. And this class is kind of like a manager for the geometries you're going to use. So it's going to call a function, the update function from these geometries, and it's going to pass the object that you're trying to render, which is going to be the buffer geometry you're trying to render. So it uses that class that initialized there in the beginning inside of the project object function, calling this update and passing the object, which is the geometry you're trying to render. And then this one is going to get the attributes from that geometry by calling this get attributes from the buffer geometry. And that's going to return a map with the map that was created there in the beginning that I showed, which maps the name of the variable and the data that the variable is equivalent to. And then it has another class that initialized in the beginning, which is the attributes class, this class here. And it calls the update function from this class that initializes, because you can see that when initialize this here is passing the attributes as an argument to the initialization of this class here. So it's gonna call the updates. So when it calls the update for this class here, it's passing the current geometry that is gonna render. And then it's gonna use this class, which is the attributes class that is defined here, because it passed as an argument to initialize class. It's going to call the update for this class. You should try to. Which is this function here. And it's passing the current attributes that you want to update. Because this thing here is going to be the attributes from the geometry. So like the way to think about it is that the geometry you're passing here is kind of like the buffer geometry. Let me see if I can find. So it's going to be, you're accessing this value here, which is an object that has the mapping that is created here. So mapping position with data, and you are accessing this value here, here. So this geometry attributes becomes that object here, this object here. And then you're looping over that. So each one, so you can imagine that for the sphere, for example, would be position, the name. And the value would be, which is the value, this value here, will be the data, which is this float32 buffer attribute that is equivalent to the position attributes. And this thing is a class that holds the information for, it inherits from these buffer attributes, which is also the base class that is used to manage the attributes. And then it passes the array of data converted to float32. And this has some specifications of how the thing works. But it calls the attribute, the update from this class here, passes this value, which is the float there. So it's calling this function, passing this attribute, which is this buffer attribute here, or the float, or this new float32 buffer attribute here. It's going to become this value here. And the buffer type is going to be array buffer. And then is on this function for the first time that it creates the buffer. So it creates the buffer that is going to be responsible for receiving the data from this geometry class and replacing the variables inside of the shader with that data. But that's the part that is confusing because it creates the buffers first. This happens before it creates the program, because I'm going back, explaining back from the beginning, right? So this happens on this function here, the project objects, and this function happens before the program is set. So first it creates these buffers based on what I just explained. Either creates or updates, but I'm thinking more about the first time that it's going to render because it makes it easier to think about. And this one is just going to create, just going to call some WebGL functions to actually create a buffer. And I think there is some stuff here related to caching the buffer as well. So you can use it later. So it just returns it as an object. Is caching on these buffers here. So if you don't have it, then the first time that you're calling these buffers, you're not going to have this. The data is going to be undefined, so it doesn't have. So it's going to cache the attribute, which is the float32 value, which is the class that holds the data for that attribute, and it's going to map that to the buffer that is related to that data, and it caches inside of this class here. It does that on this project objects function. Then you go on with the pipeline until you get again to the set program function. Then this initializes the program class that I just explained for the uniforms. And then after this class here is going to call this function here, which is binding states setup. And this binding states class is also initialized in the beginning here. So the key to understand is that it makes the connection between the program class and these buffers through this binding state class here that initializes here. Because you can see that this class receives the attributes, which is this class here, to initialize. And the geometry also receives the attributes and receives the binding state. So they're connected through the attributes. You can, like, a good way to think about it is that attributes is the class that manages the values inside of the vertex shader, the variables that you're using inside of the vertex shader. And the geometries is the class that manages all the geometries you are going to use when you render. And then the binding states is like the bridge between the two. So I did this thing here. So yeah, geometries receives attributes and binding states. And binding states receives attributes. So at this point here, after it sets the program, it's going to call on the main rendering cycle. It's going to call the setup function. So let me find this. So here, that's the same function that I was just talking about. It's going to be, after it does all of those things that I explained there when I was explaining the uniforms, it's going to return to this function here, and this is going to be the program that initialized there. And then this is just getting some values from the geometry you're using to determine the draw range and the start and end, and also the position. So if I remember correctly, this is to determine whether or not the geometry you have has a position attribute or not. But I don't remember. Yeah, I think that it has to be like that because, yeah, this is the geometry you're trying to render, and then the attributes, which is the object that I just explained, and then it checks to see if you have the position. So if it's different, then fine. Like this stuff here is gonna be this thing here. And a good way to think about it, about this, is that the data you're passing is just an array of floats, and you have both the size of the data that you're passing, which is just the amount of floats you're gonna send for determining each point. So for example, if you have vector 2, you're sending 2 floats to determine the point. But if you have vector 4, then you're sending 4 points. So you have the array of data and you have the type of data. And then that type of data determines how many floats you're going to use. So you're like dividing the whole array based on the size of the type you want. And that's going to determine this count here, because it's how many points you have inside of the array to send to the shader to render stuff. So this is, you can see here. So for example, you have these vertices, which is the floats, array of floats, and then the size of each point is going to be 3 because it's a vector 3. So the count is just dividing the size of the array based on the size of each point, which is going to be 3 in this case. And then you have this draw range, which is going to determine how many points, how much you want to consume the array. So the start, you have the start and the count, which are going to determine how it's going to determine the draw calls, which is this part related to this part here. So that's pretty much what this logic is doing, is determining how you're going to consume the array. And then on this call here is the thing that you're going to pass the count and the start, and this is the function that is going to draw, which is based on another buffer, this buffer render, which is initialized at the beginning. But it's just doing draw calls from WebGL to consume the array you set up on the buffers that I just explained. But this function here from the binding states is the one that is going to make the connection between the attributes on the buffer and the attributes that is set up. The buffers that is set up sets up on the project object function and the program class that actually has the values of the values of the attributes inside of the shader. So it's calling this function here, passing the object material and program. And then this has the logic to figure out where it is precisely on this function here. So what this class also does is to cache the states. So if you don't have the states, you're just going to create an object based on the geometry and program you're passing, which is this function here. So what this function does is just creates veil, which is something that WebGL and OpenGL uses to create, to hold the state of the buffer. So it's just creating this object here that is going to use to cache so that it has the information on the next rendering cycles. So it's pretty much caching the state, which is going to be this object here, which is going to contain the information. This object is the value of this veil, this vertex array object, which is something created with WebGL. So you guess the state here. If they are different, it binds the buffer. So this is going to be VAO, which is created with WebGL. Then it calls other WebGL function to bind the buffer. And then on this one is the one that, if I remember correctly, yeah, this function here, the get attributes. So this program is the program that was initialized on the set program function, that or the get program function that creates the program. So this program here is going to be the program class, and this function is going to be from this class. So it's just this, it's calling this function here. So in the beginning, it's not going to have the attributes cached, so it's going to call this function here. And this is the function that actually uses WebGL to get the active attributes. So it's just getting the values of the attributes that are used inside of the shader based on this and storing on this n, and then it's looping over them. And then it's creating this cache here on the attributes and then returning this. So this is the thing that is going to allow you to get the location of the variable. So for example, I think it doesn't have here, but each one of these variables is going to have a location. You can specify, I don't remember exactly the code, but it's something like layout 0 or something like that. So you can imagine that each variable has a value that is going to be probably an integer, I'm not 100% sure, but that integer is going to represent how you can access that variable in the shader to pass the data to it. And you need the location in order to be able to update the variable, because you're going to use other functions from WebGL that you have to specify which location the variable is at, so you can send the data to the variable. So this is the first, this is the function that connects the buffers that it sets up on the project objects and the program class that sets up later. So it stores all the locations on this variable here. I think that's pretty much all that I want. Maybe I think I'm gonna continue. I don't remember if I know what happens after. I think I didn't spend. Oh, let me go back to this one. I didn't look too much into this. I'm gonna look at it now. But it's probably because the challenge here is obviously knowing exactly what the values of these variables are, to know exactly what is the control flow in the first time that it renders. But I assume that it's going to call this setup vertex attributes here in the first time. And this is going to be the function that's, yeah, this is the function that actually sends the data from the buffers that initialize those project objects into the program values that it just got there on the beginning of the function. So it's initializing attributes. Just gonna get attributes here. I think I'm gonna stop here, but it's pretty much that's what I wanna talk about. And it's probably gonna be one of these functions here that it uses to update the actual shader values. Yeah, so it's calling WebGL. So this function here, it's you specify how WebGL is gonna consume the buffer you set up there in the beginning, based on the data you're sending, to replace the values of the variables inside of the shader with the actual data you have on the class. So you can imagine like you're specifying the location, which is going to be the index of this variable here. Let's say this location is 0. The value of the index is going to be 0. Then you specify what is the size of the variable. So the example of the sphere geometry will be 3, because 3 floats, because each point has 3 floats. Then you specify the type. The stride is how much to the right you have to go to get to the next point. So it's like this function is like consuming the buffer, which is the data you pass through the buffer geometry class, one point at a time, to replace the values of the variables inside of the shader. Should do the calculation, which is going to be the GL position, which is the actual final point you're going to have from the vertex shader. Then WebGL is going to take that GL position, and then later on is going to call the fragment shader code, which I just explained with the uniforms and stuff, that you use to use the material class to update the uniforms throughout that cycle. And then after it does that, then you're going to call the draw calls that I also explained there. At the very end, after it does this draw calls here, the render that actually are going to render the thing. So I think that's pretty much it. Let's see if I can go to the buffer. It's just calling these functions here. So the mode is depending on what kind of thing you want to visualize. Either you want to draw triangles, points, or lines. Because the highest the GPU can go is just draw triangles. So everything is based on triangles. And then the actual draw call you do is this one. So it just uses GL again to draw the arrays based on the start and count, which is the stuff that I just explained from the geometry, which is the beginning of the array with how many points each array actually has. And then this is just related to some information that they allow you to get. And this is the final call that draws everything. Then after it does that, obviously on the outer loop that you put the render function on, just gonna keep calling this stuff, and then the other times it's just gonna check to see what it has cached or not. And but if you update a variable, it's just gonna hit other parts of the control flow, and then it's just gonna call like similar functions. The example there is just gonna call the update buffer instead of creating the buffer. But I think I'm gonna stop here. So I think that's everything. Hopefully it's not too confusing. It was very confusing to me. And that's parts of what I'm trying to do, but I'm trying to do on C++. I'm just gonna simplify everything, and then I'm gonna put all this logic here, because that's the part that I didn't like that much. They initialize all this stuff in the beginning of the render class, and I'm gonna try to transfer all these classes to the program class, and then just create the mapping first, and then put all this logic of handling the attributes and uniforms inside of the program class, which I think makes more sense. But I think that the reason why they did it this way is because of the way that 3GS evolved, and because there is a bunch of different applications of how you can use 3GS, so it becomes harder to think about the design. But yeah, so I'm gonna stop here, and probably next time I'm going to try to do or continue to do the project that I'm doing on C++. So